seen the movie Brother Bear?
No. No.
Such a good movie.
We're doing next test day.
It's a recommended movie.
Okay, so when the differences are the same, then we know that we're linear. And if we were doing a sequence here, what would be the common difference? It would be arithmetic, and the common difference would be -2. All right, what about the second one? Again, these are all evenly spaced, that's perfect. All right, what's happening here? Let's see, this difference is 1 and 3 and 5 and 7. That tells me it's quadratic. That is a quadratic function because the second differences match, right? Second differences match, so we're quadratic. So this is not linear, it's not exponential, it's not arithmetic, it's not geometric, it's just some quadratic function. Perfect. All right, what about the next one? Again, this is critical. That is important. All right, so let's see. This one's going up by 1, 2, 4, 8. What do you think about that? That's exponential because the differences are all being multiplied by 2. They're increasing by times 2. That makes it exponential. And if you were writing a geometric sequence, the common ratio would be 2. And finally, the last one. 5, 10, 15, 20, okay. Those are kind of strange numbers, but they're all evenly spaced, so we're good. -40, I'm looking at the differences now. I'm looking at the differences. -20, -10, -5. What do you think about that? Exponential. And this time, what is our ratio? 1/2. 1/2. We're multiplying by 1/2. You okay with that? All good? All right, let's look at number 2, a little word problem. Go ahead and read it. So it's geometric, right? Everybody good with that? They tell us it's geometric. If you are only given 2 terms, you can't tell. You have to be told. And so he's telling us it's geometric. Now, what does that mean? That means that to get from here to here, from this term to this term, I am multiplying by r 3 times. Does that make sense to everybody? If you're geometric, here's the 3rd term, 4th, 5th, 6th term is 140. To get from here to here, I am multiplying by r, multiplying by r, multiplying by r. So I am multiplying by something 3 times to get from here to here. Do you agree with that? Okay, how can we find that thing? That thing that we would be multiplying by? What would we do?
140 divided by 43.
R cubed is 140 divided by 43. Remember, you are multiplying. So the total multiplication is whatever that is, and I gotta do it in 3 steps, right? So can we do that on our calculator? Figure out what our R is?
How do you do a cube?
Well, you have a cube root in your math menu. I prefer myself, I remember that cube rooting is the same as raising to the 1/3 power, so that's how I do it. But you do have a cube root button in there, in your math menu. So did you get about 1.482? Okay, I'm not going to, write that down. That's my R. That's what I am multiplying by to get from here to here in 3 steps. Okay? Well, what's my objective? My objective is to get from here to here, right? Well, how many steps is that going to be? 4? To get from 6 to 10? And I'm going to be 4 steps. I need to take 4 more steps. And I'm going to take those 4 steps by taking this R value that I found, the 1.48 thing, and multiplying it 4 times, right? So I'm going to do that. So I'm going to take the number on my calculator, I'm going to raise it to the 4th power, and times it by 140. How many people have heard the rumor?
675.
Nearest whole number would probably be 676, right?
My calculator rounded differently.
No, the calculator doesn't round differently.
No, like it made me round differently. Really.
No, it didn't.
I swear.
You're going to break my heart.
It's called,
No, do not read it.
What did you say the answer was?
You're going to break my heart. Why am I breaking my heart?
maybe you
No,
just need to charge your
no,
camera.
because you rounded that number off. You should use that number right there.
Do I just do second and this to get an answer? Oh wait, okay.
But now you gotta go back. So 676 is the answer. Is that what you got, everyone, except Cole? Who's working on it? Right? All right, example 3. Large theater has rows of seats. 5th row is 31. Now, this is arithmetic. 5th row is 31. 11th row is 49. And we want to know the 25th row. So what's going through our head?
49 minus 31
It's arithmetic. We got 6 steps to cover 18 units. So each step, it's arithmetic, so each step has to be 3. So now look at where you're at, guys. You're at 11 going to 25. So you're gonna have to add 3, how many times?
14.
14.
42.
49 plus. Did you get 91 seats?
Crazy word.
We had 6 steps to cover 18 units, adding. So each step had to be 3. To get from here to here, we have to take 14 more steps, so we just add on 14 of these. Okay? All right. Jerry's greeting cards. Flip to the check your understanding part of that. Check your understanding on Jerry's greeting cards.
Dude, I want chili so bad right now. Chili.
So it's actually the next page.
Crazy word.
No, it's
All right, you and your partner figure it out. 1, 2, and 3. Let's check your understanding. See where you're at.
It's good. Oh,
This word, you said we're on this, right?
what?
Yeah, where it says
Back.
lesson
You try to Wendy's
4.3,
chili?
linear and exponential.
I don't know what
Check
she's all
your
about.
It's good.
You're wrong. I don't know you're wrong.
It's so good. We did it all the time on road trips. I get excited for it. Linear function.
Does anything about that table they gave you bother you at all? They're not equal input intervals. And when they're not equal input intervals, the only kind of function you can test for is linear. Because linear will have the same rate of change, right? So you can calculate your rate of change and it'll be constant if it's linear, otherwise you can't tell what it is.
But isn't like the thing
They use the whole table.
Oh, we do?
Yeah, they use the whole table.
Writing.
You can't just pick and choose out.
In what?
You gotta use, you gotta use everything you gotta get.
It's like a 40-letter alphabet.
I'm slow.
The model equation is for like an exponential function.
Okay, we're working on it. You work on it.
I just always was doing one of
Thing.
Looks right, yeah.
Did you guys get number 1 to be linear?
Yeah.
Yeah, I went ahead and found the rate of change. Remember how we find the rate of change? We take y minus y and divide it by x minus x, slope. And the rates of change, even with the difference being, over here, the rates of change all came out equal. So that is a linear function. Does anybody have a question about that? Everybody good? Linear, okay. So then you had to write a linear function that contains these 2 points. So what did you do first? Gus, what did you do first here? So you know the slope? So 7 minus 63 over 3 minus 1, what is that? That negative 28, that could be totally wrong. Is that right? So then you picked a point and said y minus 7 equals negative 28, x minus 3, y equals negative 28x. Oh my, is that right? That would be 84 plus 7. Yeah, I think that's right. Does that look okay? People? Yeah, Alex?
Do we have to like move this stuff over and simplify it though, since it's not asking for, that form?
Okay, here's the deal. It says write the equation of a linear function, so I should be able to express it as a function, which means y should be by itself. But you're right, these are all I mean, that's the same as this, it's the same line. It's hard to write it as a function when y is not by itself. Okay, now how about an exponential through the same 2 points? Remember, if all you have is 2 points, you don't know what you've got, they have to tell you. So now they're telling you your exponential. What do exponentials look like? This is not really fair because we're going to talk about it in the next set of notes more. But think of your BFFs. What did that look like? What was your equation of your exponential? Y equals,
63 times 1/3 x.
well,
8 times.
you're giving me the answer to this question, but what did it look like?
8 times
E to the x, right? That was what we called our exponential. I'm gonna put a 1 there. Your exponential is something, like 1 or something, times a base to a power. And when we studied the BFFs just in general, the general exponential, the base was 2.718, but that can be anything. So what we're saying is, this is the form of an exponential. Just like this is the form of a linear, that's the form of an exponential. And they're telling us that 63 has to equal something times something to the first. That's what this point says. Would you agree with that? And then it also says 7 has to be something times b to the third. Now those are easy enough numbers, you could figure this out, but I'm kind of giving you, this is how you would figure this out if you had to, with like awful numbers. You ever thought about that? How I would solve, this is a system of equations. How could I solve that, Cole?
Get them both equal to A.
Oh, that's a great idea. So we know A would be 63 over B. Would everybody agree with that? A would be 63 over B. What else would A be? A would be 7 over B cubed. So 7b equals 63b cubed. Or 1 equals 9b squared. Is that true? Is that okay? How did I do that? What did I do?
You just simplify.
I divided by 7b. Normally, I would be absolutely screaming about dividing by a b, because normally we don't divide by variables. But why is it, why don't we? Why don't we divide by variables? We don't know if they're 0 or not, right? Why is it okay in this problem? B can't be 0, right? This wouldn't make any sense if B were 0, would it? So it's legit to divide. And that means What's my B?
1/3.
1/3.
Wouldn't it be easier if you just said r squared is 7 over 63?
That'll work too. We're just ready to talk about that. Here's what I just kind of want you to see how to solve a system of exponential equations.
Okay.
Okay, but yes, we're gonna talk about that in a second, thinking about it in terms of a sequence. Okay, so then if B is a third, then, just like always, I can figure out, what my A is. What's my A? 189? Is that right?
Oh, 21.
Oh,
It's 189.
Wait, am I?
And what are you on about? Multiply
Oh
by
wait, I
three.
thought you had to divide it by 9.
So-
That was stupid.
B was a third, so I put a third right here. And I said 63 equals A times a third. How do I solve that equation? Divide by 1/3, which is timesing by
Three.
3.
For
Right.
some reason, I thought she was asking us to divide 189 by 9.
So I'm trying to write my equation, guys. So y equals 189 times 1/3 to the x. So it said, write the equation of an exponential function, there it is. Now, you guys have realized, because you're smart people, there's more than one way to do the problem, but that's one way. If you are solving for an exponential, this is your base equation, your base form, plug in your 2 points, get A by itself and set them equal to each other, cross multiply and solve. Okay? Now, Mr. O'Brien said, wait a second. This is like saying A sub 1 is 63 and A sub 3 is 7. Right? So we have to go 2 steps and cover how much? Now remember, this is geometric. So here to here, that division is a total of, or is 1/9. I have to do a total of a 9. So if I'm doing it in 2 steps, then my ratio, which is the same as my base, the ratio is a third.
Can you write your final equation? Is it okay? Because the 189 is like, I guess it would be like A to the 0, or the 0th
Yep,
term.
yep,
So
if I'm thinking of a sequence, yeah.
if you do 63 1/3 and minus 1.
Yep, absolutely. There are lots of different ways. You can make your first, you can make this guy whatever you want and adjust your exponent accordingly. Sure, lots of different ways to do that.
Would R also be negative 1/3?
Great question. If it's a sequence, yes, but I want you to look at, where was my problem?
It says it's an exponential.
It says it's an exponential function. And exponential functions look like this, or they look like this, okay? If you let R be negative, which it can be in a sequence, R can be negative. What does that do to your terms? It makes your first term positive, your second term negative, your third term positive. See what it does? It looks like this. So if you are in sequence land, absolutely. If you are in exponential function land, the base must be positive.
Correct.
This must be positive. Okay, that can be negative, that turns your picture upside down, but that has to be positive. So it's one of those distinctions. Exponential functions and geometric equations are absolutely tied together, but they have differences between them. Okay?
Thank you.
So not in this case, no. Okay, all right. And did you get number 3 yet? Have we gotten number 3? Geometric, which of the following could be used to generate the terms of the sequence? Well, A and B are just dumb, aren't they? Yeah, A and B don't even make any sense because it's supposed to be geometric. Alright, so pitch those. Alright, so exponential function with a y-intercept. Okay, be careful. Your y-intercept would be your 0th term. Okay, so which is right? Is the y-intercept 1.5 or is the y-intercept 6?
1.5.
Then D also says it's domain of all real numbers, so that also.
That's crazy. So it must be C? I don't really even have to, I mean, I hope it's C,
It's a brain mouth one.
because none of the rest of them even make sense, you're right, as an answer. Okay, all right, so 2.2 will be due on Thursday. And I'm gonna stop there, and we are going to do 2.3. Then we'll have a little quiz after 2.3.